All right, so more of the same. I'm just going to explain this real quick. There's really not a whole lot to write down. We have a reflection question at the end, but in this particular case, do you notice any opposites? Well, hold on. The short answer is no. 3x and 3x are not opposites. How would I make them opposites? What does one of them need to be? Negative. So instead of adding, we could just subtract the bottom. The tricky part about subtracting the bottom is when I say 3 minus 3x, that's 0. But when I minus y, what am I really doing? Adding. So what's 3 plus 1y? 4y. And then remember, when I minus 6, what am I really doing? Adding. So what's 6 plus 6? 12. So if I do that, I get 4y equals 12. Divide both sides by 4, right? And I get y equals 3. Am I done? No. Nope. What do I got to do? I got to go back and find the x. So it doesn't matter which equation you choose. We'll use this one, the second equation. But wherever there's a y, I'm going to plug in a 3. So then I end up with 3x minus 3 equals 6. What do? I'm going to add 3 to both sides. When I add 3 to both sides, these cancel, and I get 3x equals negative 3. What do? Divide by positive 3, and I get x equals negative 1. So then my solution is negative 1, because that's what I got for x, comma, y, which is 3. Check the solution by graphing. If I plug in 0 for y, my x-intercept is 2. If I plug in 0 for x, my y-intercept is 2. So that's this equation. I have an intercept here and an intercept here. Same thing here. If I plug in a 0 for y, my x-intercept is negative 2. So that's going to cross right here. If I plug in 0 for x, I'm going to have a positive 6. So that's off the chart. It's way up here. Positive 6 is like up here. Okay. So what I'm saying is my x-intercept of 2 is just going to be 2, 0. And this will be 0, 2. Over here, this is going to be negative 2, 0. And then this one will be 0, 6. And when we look at where they cross, they do cross at negative 1, 3. Okay, so the graph, if I've done all the algebra right and I graph correctly, I should get the same answer for both. Okay, and remember, if you don't remember this, these are in alphabetical order. It's always x, y. All right, reflection. What would happen if you added the original equations? Well, let's look at that. So the original equation, let me zoom out and write it down. The original equation was 3x plus 3y equals 6. And then if I just added 3x minus y equals negative 6. So if I just add those up, I get 6x plus 2y equals 0. Now, algebraically, there's nothing I can do to get x or y by itself without having the other variable. I could subtract 2y, right, and do that, and I get 6x is equal to negative 2y. I could divide everything by negative 2. When I do that, I'll end up with y equals negative 3x. So I get negative 3x equals y. Well, that's the relationship between x and y, but I don't know the solution. So I don't have y equals some stuff. Well, I mean, I do, but I don't have y equals a number. So instead of saying stuff, I should put the number sign. This is not hashtag. This means number. And I don't have x equals a number. I'm always going to have the x and the y. So because I can't do that, adding in this case isn't very helpful. So you could say it won't work. That's not the very formal answer. It won't work. We have to subtract it. We have to eliminate either the x or the y. Does that make a little more sense?